Welcome to a tutorial on analog electronics, and today we're going to discuss about the field effect transistors. Okay, so of course you can understand from the fact that this is a special type of transistors, much different from that of the BJTs. Okay, so it's created back in the 1952. Okay, and of course this is a analog device, and that goes without saying. So if we would take the initials from their names over here, I mean from their actual name, okay, so we get the shorter form of expression in order to describe this device. So that's known as the FET. Okay, that's the field effect transistor. And till date there have been a lot of improvements in FET technology, and we have a lot of types of FET available today. So in this tutorial we'll be basically concentrating, or rather directing our focus onto the junction field effect transistors. That's the Aj Fet over here. Okay, so let's just quickly move on to the structure of a Aj Fet. Okay, I'd like to change the color first. So there you go. So we would discuss first the structure of the Aj Fet. Okay, so hold on for a second please while I just introduce the diagram. Okay, there it is. So this is basically what the structure of a Aj Fet basically looks like. So here we have, as you can see here, okay, so there is this yellow outline that represents an N-type semiconductor device. Okay, so this is basically an N-type semiconductor device. Okay, this is an N-type semiconductor. Okay, there you go. Right, and it is of course lightly doped. Okay, it's lightly doped, and materials used could be either silicon or gallium arsenide. Okay, it's not a problem. Okay, so this lightly doped N-type semiconductor actually serves as a channel. Okay, so we like to call it the channel. All right, so I'll tell you why we'll call it a channel. Okay, so before that let me just mention one more thing over here. So this N-type semiconductor bar, okay, as known as the channel, okay, has two other semiconductor p-type regions, okay, on its two sides, as you can see over here the lines drawn in light blue over here. Okay, so denoted by P plus. So now the plus sign over here, alright, I'll use the white color, so that's my mistake there, don't mind. So this P plus actually with this positive sign on represents that the P region over there is heavily doped. Okay, so there you go. So we have a heavily doped p-type semiconductor on the sides, semiconductor regions basically on the sides of this N-type semiconductor bar. Okay, so actually the three-dimensional representation would appear as something like this. It's the p-type region is basically rolled about the or rather wrapped around about the N-type semiconductor bar. So this is the region basically which I'm talking about. Okay, so if we just take the transverse section, that's the TS, just cut it through and take the TS, okay, the inside will appear as something like this. So that's exactly what I'm just trying to mention over here. So apart from that, we can see here that there are certain metal contacts. Okay, so this is a metal contact. Okay, so the metal contact is also they're referred to as ohmic contacts. Okay, and they're provided in order to draw the metal terminals through which will make electrical connections to the Aj Fet device. Okay, so here as you can see that a metal being connected to the N-type semiconductor is probable to give rise to problems such as metal semiconductor junctions, and we don't desire that over here, as it'll just give rise to a rectifier like operation. So in order to curb off this problem, okay, so what is generally done is that you can see that there are certain dots in the N-type semiconductor bar, so that represents the doping profile. Okay, so basically you can see that at the areas, okay, at the sides where the semiconductor and the metal contacts are formed, over there the density of the dots is higher, which represents a high density of doping. So I would just like to mention it over here. So that's a high density of high density doping over there. So there you go. So the doping concentration obviously is higher at the sides of the semiconductor, where it just gets connected, or rather forms a contact with the metal caps. Okay. Other than that, inside the n-type semiconductor bar, the doping is, of course, as said earlier, is very light, as the whole thing is just lightly doped. Okay. So there you go. That's basically the structure of the Aj Fet. Okay. And now, as you can see, that if we just take a fresh diagram over here again. Okay. So there it is. So now if we would go towards the electrical connections, okay, so then if we would connect alright, if we would connect a voltage source, okay, so just hold on for a second there. So while I just connect the voltage source over here, so there it is. If we would connect this voltage source, okay, across the two metal caps connected on the two sides of this n-type semiconductor material, and if we would also connect another voltage source, okay, at the terminal connected with the p-type semiconductor material, okay, with one terminal from the terminal connected to the p-type semiconductor, while that the other terminal coming from the the negative terminal of this first voltage source that I've connected over here. So there you go. If we just connect voltage sources in this way, then we would or rather, sorry, that'll be just a reverse over there. Yeah, that's right. So just don't mind my mistake over there. It's just happens due to lack of attention. So apart from that, now we can see that this p-type semiconductor material having this terminal jutting out of it over here, okay, this terminal is basically referred to as the gate of the Aj Fet. Okay, so now the gate terminal always needs to be reverse biased. Okay, so that's why we've connected the negative terminal of the source over here. So since this is a p-type region, okay, so apart from that, now the voltage source that we've connected over here about the n-type semiconductor material, okay, so here we can see that a current due to this voltage source being connected across it would flow from the left side. Okay, I mean it would just, the current would just enter into this semiconductor bar through the left and would come out through the right, while the electrons, okay, would just enter into the same material through the right, but would exit through the left. Okay, so there you can see from this direction of electron flow, okay, which is of course the majority carriers of this semiconductor material over here, what happens is that the terminal, okay, so that's on the right, so the right terminal through which the electrons enters into this n-type semiconductor region is basically referred to as the source. Okay, and on the other hand, the terminal that's on the left through which the electrons are basically exiting the n-type semiconductor material, so that is basically referred to as the drain. Okay, so there we go. We have three terminals on the Aj Fet. So the Aj Fet is basically a three-terminal device. Okay, that's the gate, the source, and the drain. So as you can see, okay, and now the voltage that is connected across the drain and the source is basically referred to as the drain source voltage. Okay, abbreviated as VDS, and on the other hand, the voltage source connected to the gate, okay, with respect to that of the source right over here, that's the connection, is referred to as the gate to source voltage, okay, abbreviated as VGS. Okay, basically. So there we go. That's the circuit connection of the the electrical connection of the Aj Fet as is practically done. So this is the practical connection, or rather practical circuit of the Aj Fet, okay, as it's to be used. All right, so as I said there, that the gate terminal is of course reverse biased. So what happens is that we need to apply a negative voltage to the gate terminal as such. So applying a negative terminal, applying a reverse bias at the gate terminal, okay, it leads to the formation of a depletion region, okay, deep within the n-type semiconductor material. So here we go. As I said, that this n-type semiconductor material would be called a channel over here. So there you go. So now this channel, okay, is basically the pathway of the flow of the current or the charge carriers. That's electrons in this case. So what happens is that due to the reverse bias voltage at the gate terminal, the depletion region basically forms deep into the channel. Okay, that's the N channel. Okay, so now what happens is that the reverse bias also causes the depletion region to form inside the p-type semiconductor material as well. But that is that depletion region extends very little into the p-type material, as this thing is highly doped, while the channel is lightly doped, so it extends more inside it. So this phenomena basically leads to a decreasing of the effective width of the channel. So it just reduces the effective channel width, so which reduces the effective current conduction area. So this way what happens is that if we would now the reduction in the effective current conduction area inside the channel leads to a decrease of the current through the channel specifically. So now we can see that by controlling the reverse bias voltage on the gate terminal, we can of course control the amount of current flowing through the channel. So basically that gives us a very important feature of the JFET, that gate voltage controls, okay, so gate voltage controls the current, controls the channel current. So there we go. So, and due to this reason, it's also referred to as a voltage controlled resistor. Okay, so basically why am I referring to it as a resistor would be the obvious question. Okay, so the reason is that because of the fact that whenever we reverse bias this thing and the channel width decreases, the resistance inside this channel also increases, that further prevents the current from increasing, or rather a lot of current to flow through this channel is just prevented by the increasing resistance inside the channel region over here, due to increasing reverse bias voltage and the development of the depletion region. So basically these are the depletion region over here. So there you go. Right, so there goes the depletion region in pink. Okay, so having said that, we get to know other two features of the JFET. That's it has only a single charge carrier. Okay, so it's a single charge carrier, and there is no recombination inside. Okay, when just offered to the path of the flow of the current. Okay, whenever charge carriers flow through the channel, there is no recombination, as they do not pass through any kind of junctions over here. So basically, having said that, if we would like to show you the circuit symbol for the JFET over here. So there you go, that's the circuit symbol, that's a drain, that's a gate, that's a drain, and the source. Okay, so this JFET, as you can see, has the N-type semiconductor material making up its channel, so it's just referred to as an N-channel JFET. Okay, so there you go, it's an N-channel JFET as such. And now if we would just take the theoretical condition of the gate terminal being forward biased, then from the p-type side the current would just flow into the n-type channel. So that's denoted by this arrow mark over here. So that's basically the symbol of the n-channel JFET. So now if we would use this to construct the circuit that we have just drawn above, okay, so then this would just look somewhat like this, as I'm just gonna show you over here. Okay, so there you go. Alright, so I'll just add the voltage sources over here using red as well. Okay, so there we go. Since it's p-type, so it'll be reverse bias, so we have a negative part of the cell that's connected to the gate. Okay, so there we go. And apart from this one, we get to see that the source is always is kept at the negative terminal over here of the battery. Okay, so there you go, that's the source, that's the drain, and that's the gate. So this is basically the circuit okay, that we have just drawn over here using the n-channel JFET. So apart from that, okay, there's also this another type of JFET that I'm going to just show you over here. Okay, so there it goes. So this is basically the diagram of the other type of JFET which I wanted to show you. Here, as you can see, the channel, okay, so this is basically the channel over here, is basically made up of a p-type semiconductor material. So this type of JFET over here is basically referred to as a p-channel JFET, okay, since its channel is made up of p-type material semiconductor, while the previous JFET, okay, since its channel was made up of n-type semiconductor material, would be referred to as an n-channel JFET. Okay, so there you go. Sorry, there I didn't mention the JFET term over here. Yeah, that's right. So if you all would like to see the equivalent, as I've just shown over here, it's the equivalent circuit of the p-channel JFET as it would be connected in the circuit. Okay, so we can see here that both the JFET circuits over here, okay, have their source grounded, okay, as you can see. So basically both of these circuits are in their common source configuration, okay, where the source is grounded. I mean, and this is equivalent to the common emitter configuration in that of BJT. Okay, so apart from that, if you all would like to see the circuit of this this circuit that I've just drawn over here with the help of the circuit notation, then the circuit notation for this, or rather the circuit symbol for this one, would be given as something like this. Here, note the arrow mark, okay, is just reversed to that of the n-channel JFET as I've just shown you over here. So there you go, that's the circuit symbol for this type of JFET. And if you all would like to take a look at the circuit that's just be represented by the circuit symbol over here, so that's gate, drain, and that's source. Okay, so just hold on for a second please. And if we would just connect the terminals to the respective voltage sources, then only the circuit would be just completed over here. So as per the diagram, we would have the source connected to the positive terminal of the battery. So there you go. So there it is. So we that's the connection to the source, okay, over here, and the gate would be kept at the at the positive voltage, right? So there you go. So that's how the circuit would look like if we would just used the circuit, the circuit symbol over here. So that's the circuit symbol of the p-channel JFET. Okay, so there you go, circuit symbol p-channel JFET. Okay, so there you go. So apart from that, this is obviously the circuit as drawn using its symbol over here. So there you go. So with that, we would just like to wrap up our discussion over here on the JFETs. Okay, hope you've enjoyed our tutorial. Okay, and don't forget to watch us on the next tutorial. Until then, is just thank you for now, and thanks and goodbye.